I'd like to talk a little bit about the CubeSat standard and how that's really kind of a revolutionary technology for spacecraft development. The thing that made spacecraft so difficult and so expensive to design in the past was that each sort of platform was unique. It was very difficult to manage the complexity because there were a lot of options and alternatives, and spacecraft are very expensive to develop. So what the CubeSat standard does is it sets an envelope, a specific shape and size, and this is an example here, about a 4-inch cube for the envelope for the entire spacecraft. Now, that's actually quite a challenge to put all of the functionality that you need in a spacecraft into this much space. That's all the power, all the communications, the computer to manage the mission, the payload. But what this form factor did was it provided a standard interface for the launch vehicle. So now the P-Pod that Cal Poly developed could be mounted to a rocket, and it was a well-known form factor, it was a well-known mounting system. So that could be designed independent of what sort of satellites were going on inside. And then the P-Pod could accommodate 1U CubeSats like this. This is effectively 10 centimeters by 10 centimeters by 10 centimeters. You go 10 centimeters by 10 centimeters by 20, or 10 by 10 by 30, and have a complete satellite about this big. And having that interface where you could mount the P-Pod, and the launch provider could provide that interface to hold the P-Pod on their launch vehicle, and then the CubeSat developer could go to develop their CubeSat and then plug it into the P-Pod, really was a revolutionary change for spacecraft development and accelerated the development of small spacecraft. We started in 2006 with Kentucky Sat as kind of as our focus, and we were actually calling ourselves the Kentucky Sat Consortium, or Kentucky Sat program. And then we broadened into Kentucky Space pretty quickly. Launch opportunities are very hard to come by, orbital opportunities. So we started looking at suborbital opportunities and high altitude balloons, and really kind of changed the scope a little bit to Kentucky Space. And the goal of Kentucky Space is to provide the infrastructure, physical infrastructure like the clean room here, manpower infrastructure in terms of the students going through the pipeline, able to design spacecraft and subsystems and put them all together, do all the systems engineering and all those sorts of things, integration for launch, and maybe even get to the point where we're spinning off high-tech companies, small companies from the effort in the States. So kind of the whole package of developing the infrastructure to have a space program in Kentucky, hence the name Kentucky Space. A big component of the program is outreach and the pipeline from K through 12 all the way up through undergraduates, graduate students, faculty learning how to build space systems. And we've been very active with half a dozen major missions, lots of firsts that we've achieved, and it all really started with KOISat-1 as that kind of that initial idea. That's still our flagship mission, but we've really branched off and are doing all sorts of interesting things along with that.
Despite their small size, CubeSats actually have all the major subsystems and components that you'll see in the larger satellites, such as command and data handling. On KOISat-1, we're using an MSP430, which is a microcontroller out of Texas Instruments, and that handles all the other subsystems on the satellite, and it also interprets the commands that we send up and then executes them. Moving up, we actually have two different radio systems. We have a UHF, VHF amateur band radio, and then we also have a higher frequency 2.4 gigahertz and also higher data rate S-band radio. Our primary radio is the UHF, VHF, and the S-band is kind of a semi-experimental, trying to kind of get the higher data rates in these small packages that will make them more useful for science data. The other subsystem we have is the electrical power system that takes power that's generated by the solar panels that are on the outside of KYSAT-1 and converts that into usable power, which is stored in a pair of lithium polymer batteries that I have on board, and also distributed throughout the system in a regulated fashion in order to run all the different components. And finally, we have a payload interface module. It's a custom board that interfaces the payload of the satellite. And the payload of the satellite is pretty much just a camera. The purpose of KYSAT-1 is to do educational outreach, and with that, one of the highest impact things that you can do is actually visually see what's going on up there. So KYSAT-1 actually has the ability with its radio to interpret DTMF commands, which are the tones you hear on an old touch-tone phone. That's called DTMF, and that can actually hear those and interpret them, and then actually take a picture. And then also with its high-powered amateur band radio, the students will actually be able to listen to the satellite as it comes across. And so one of the things that we have to do in order for this educational outreach idea to work is develop some ground software and some graphical user interfaces in order for people to use them. So that's what we're in the process of doing right now, is actually developing these different user interfaces that we can deliver to different users. There can be more of a power user type, and then also a more basic one for the beginning teacher or the beginning student. And so KYSAT-1 has an operational lifetime of 5 years. We're planning here at Kentucky Space, we're planning to do active control and active research with it for about 2 years, and then after that we're going to turn on something called digipeating mode, in which other amateur radio operators can actually send up packets, and even if it's not a proper KYSAT-1 command, it will recognize that it's not a proper KYSAT-1 command and then just reflect the packet that was sent up back down. So you can actually use it as a communication tool over very long distances. It's called crossband repeating. So it'd be going up to the satellites in VHF and then coming back down from the satellite in UHF. So it's called crossband repeater. And again, for the last 3 years of its lifetime, before the batteries go out, that's going to be the first to fail. It'll be acting as a crossband repeater. For the first 2 years, it'll be an educational tool as well as a research tool for us to learn more about the satellite in general.
We are really starting to look at finishing up our plans and designs for the outreach components and the operation of KYSAT-1, where we'll try to make it available to K-12 students throughout the state through web interfaces, where they can command the satellite to take pictures at certain points in the orbit, or they can send audio messages up, get telemetry data back down in terms of temperatures and voltages and things on the satellite. And then there are modes where students can actually just go out in the playground with a fairly inexpensive handheld ham radio and a handheld antenna, and with a little information from the internet on when the satellite will be passing over and where, they can get out and actually listen to it and send commands up to it themselves. So we're ramping those efforts up as well, and that's going to be exciting for all of us to see the satellite launch and then actually get out and see the kids' faces when they realize there's a satellite passing over, developed here in Kentucky, and they can talk to it. So for the future, we really do have a pretty generic structure for taking the bus, which again is the non-payload stuff in a satellite, the structure, power systems, communications, kind of control processor, commanding. We have a generic bus that we can attach to a variety of payloads, and it's fairly well structured the way we did it with a payload interface module, which is really the only thing that would have to change, and then we could stack another payload on top of our basic KYSAT-1 bus. And we've looked at several concept satellites of taking that bus and leveraging it. We have some other proposals in right now that kind of leverage that bus to build other satellites. So we're hoping to indeed do a series of satellites. We're going to evolve the bus. We have to, but we have that basic structure and that basic way of doing things and the commanding that we hope to leverage for several satellites in the future.